A star 13 times heavier than our sun just vanished. No explosion, no supernova, no fireworks. It simply disappeared. And for years, the evidence was sitting in NASA's own data. Nobody noticed. This isn't science fiction. This is what astronomers just confirmed in a landmark study published in Science on February 12th. A massive star in our closest galactic neighbor, the Andromeda Galaxy, skipped the most violent event in the known universe and quietly collapsed into a black hole. The lead researcher, Columbia astronomer Kishalai Day, called it the most surprising discovery of his life. And when you understand what happened, you'll see why this changes everything we thought we knew about how black holes are born. But here's what makes this story truly unsettling. The clues were hiding in plain sight for over a decade.
The star had a name. M31 2014 DS1.
Not exactly catchy, but what it did was extraordinary. In 2014, NASA's NEOWISE space telescope, a spacecraft designed to hunt asteroids, noticed something strange. A bright star in the Andromeda Galaxy, about 2.5 million light-years from Earth, started getting brighter. Not a little brighter, dramatically brighter in infrared light. It glowed intensely for 3 years. Then, in 2016, it did something no one expected. It dimmed. Fast. In barely a year, it dropped far below its original brightness. By 2022, when astronomers finally went looking for it with powerful ground-based telescopes, the star had essentially vanished. It had become 10,000 times fainter in visible light. One of the most luminous stars in an entire galaxy had simply winked out of existence. Imagine looking up and Betelgeuse, that bright red shoulder of Orion, just gone. That's what happened here, only in the galaxy next door. And that's not even the strangest part. Because everything we teach in textbooks says that when a massive star dies, it goes out with a bang, a supernova, the most energetic explosion in the universe. For a brief moment, a single dying star can outshine an entire galaxy of hundreds of billions of stars. That's how it's supposed to work. The core collapses, neutrinos blast outward, and the resulting shockwave rips the star apart in a blinding flash of light. But M31 2014 DS1 didn't do that. It broke the rules. Here's what scientists now believe happened. When the star exhausted its nuclear fuel, gravity won the battle it always fights against the outward pressure of fusion. The core began collapsing. A neutron star started forming at the center. Normally, the neutrino-powered shockwave generated during this collapse is powerful enough to blow the rest of the star to pieces. But in this case, that shockwave failed. It didn't have enough energy to push the stellar material outward. So instead of exploding, almost everything fell inward. The neutron star couldn't hold. It became a black hole. But here's where it gets really interesting. The star didn't just implode cleanly, like water funneling down a drain. Remember, the interior of a star is violently turbulent. Near the core, temperatures reach billions of degrees. The outer layers are much cooler. This extreme temperature difference drives powerful convection currents, essentially massive rivers of superheated gas churning through the star. When the core collapsed, those outer layers were still in motion. They had angular momentum. They were spinning. So instead of everything falling straight into the newborn black hole, the outermost layers went into orbit around it. Picture water swirling around a bathtub drain rather than flowing straight down. That swirling motion slowed the process dramatically. Instead of the entire star disappearing in months, the remaining material is spiraling inward over decades. As it falls, it heats up. As it heats up, it forms dust. And that dust is what produced the infrared brightening that NEOWISE detected back in 2014. Only about 1% of the star's original outer layers has actually fallen into the black hole so far. The rest is still out there, slowly spiraling inward. And that faint infrared glow, it will be visible for decades to come with telescopes like the James Webb Space Telescope. But there's something most people don't realize about this discovery. This might not be rare at all. While analyzing M31 2014 DS1, DISA's team went back and re-examined another mysterious star that vanished in 2010 in a galaxy called NGC 6946, about 10 times farther away. That event had puzzled astronomers for years. The data was fuzzier, the star was dimmer, and the interpretation was heavily debated. But with the new understanding from M31 2014 DS1, the pieces suddenly fit. Same pattern, same infrared signature, same silent collapse. What once looked like a one-off anomaly now appears to be a class of events. Failed supernovae, stars that die not with a scream, but with a whisper. And this raises a profound question. How many black holes in our own Milky Way were born this way? We know dozens of stellar black holes exist in our galaxy. Gravitational wave detectors have confirmed hundreds more from mergers across the cosmos. But we've never had a clear consensus on which types of stars produce them, or how. This discovery starts to fill that gap. M31 2014 DS1 was born at about 13 solar masses. By the time it died, stellar winds had stripped it down to roughly 5 times the mass of our Sun. Stars at that mass were always assumed to explode as supernovae. The fact that this one didn't means the dividing line between stars that explode and stars that collapse quietly might be far blurrier than anyone thought. It might not be about mass alone. It might come down to the chaotic interaction of gravity, pressure, and shock waves inside the dying star. A cosmic coin flip that determines whether a star goes out in glory or fades away. And this is where it gets personal for all of us. Because our Sun won't die this way. It's far too small. But somewhere in our own galaxy right now, massive stars are burning through their fuel. Some of them will explode spectacularly, and some of them we now know will simply vanish, leaving behind invisible black holes drifting silently through space. We're living at a moment when astronomers can finally watch this process in real time, not reconstruct it from theory, but actually observe the birth of a black hole. The James Webb Space Telescope will keep monitoring the fading glow of M31 2014 DS1 for years. And with next-generation infrared surveys, scientists expect to find more of these silent deaths, building a catalog of a phenomenon we barely knew existed. What we're witnessing might be one of the most common ways the universe creates black holes. We just never had the tools to see it before. So here's what keeps me up at night. If a star this massive can vanish without a trace, how many invisible black holes are wandering through our own galaxy undetected? Scientists estimate there could be hundreds of millions. Some of you probably have a theory about that. Drop it in the comments. A star vanished, a black hole was born in silence, and somehow that quiet death might be telling us more about the universe than any explosion ever could.